Hey, this is Mr. Preston back with some right triangles. Today we're going to be studying about trigonometry. What does trigonometry mean? Well, think about triangles. Metry is simply measurements. So all trigonometry is just triangle measurements. So why do I have these triangles drawn up here? Trigonometry is based off of similarity. If you remember that similarity means same shape but a different size. The sides are proportional and the angles are congruent. So if you look right up here, 3 to 6, I would need to multiply by 2. So 5 to 10, if I multiply 5 times 2, it's 10. I multiply 4 times 2, it's 8. So these are proportional. So using this, ancient mathematicians realized that, well, if you have similar triangles, you are going to have the same angle that relates to the same pair of proportional sides. Well, let's take a look here. This side here, I'm just going to call this across from this angle. I'm going to call this my opposite. Okay, 5 is going to be my hypotenuse. And 4, which is next to this angle, is going to be my adjacent. Remember, adjacent just means next to. So this is my adjacent. Okay, and let's do the same thing over in this triangle. So here, 10 is going to be my hypotenuse. Whatever is across from the angle, whatever is across from this angle is going to be my opposite. This is my opposite. I'm going to just put OPP for opposite. This down here is going to be my adjacent. What you'll notice here is that a lot of these are proportional. So if I do opposite over hypotenuse, so 3 over 5, opposite over hypotenuse, and this over here, my opposite over hypotenuse is 6 over 10. So what you'll notice is that 3 over 5 is equal to 6 over 10. Both of these reduce to 0.6. So this means that for every opposite over hypotenuse that's the same, the angle here is going to be the same. So that leads us to trigonometry. So we've gone through some of the terms. Opposite, adjacent, hypotenuse. We know that trigonometry is used with similar triangles. Now let's decide whether to use sine, cosine, or tangent. So these are some strange words, but there's a nice trick we have to remember them. Okay, so this is the tie-in from similarity to trigonometry. And that these are proportional. Because they're proportional, they're coming from the same angle, so the same degree measure of the angle. Okay, so find an eraser real quick. Okay, so trigonometry. Trigonometry, we have 3 ratios. We have the sine, the cosine, and the tangent. Sine is defined as opposite over hypotenuse. Cosine is adjacent over hypotenuse. Let's put hypot for short. And tangent is opposite over adjacent. Now an easy way to remember this is SOHCAHTOA. So SO, S-O-H, sine, opposite hypotenuse, CA, C-A-H, SOHCAHTOA. C is for cosine, which is adjacent over hypotenuse. T is for tangent, which is opposite over adjacent. Okay, so let's take a look at what we're talking about here. All right, so what you'll notice here is that I have one side length that's given to me, and I'm trying to find another side length. So I'm given one side length and one angle, and I want another side length. Can I use Pythagorean theorem? Well, no, I don't have two numbered side lengths. Can I use special right triangles? Well, no, I don't have a 30, 60, 90 or a 45, 45, 90. So I'm going to use trigonometry. So we're going to do what we did. We're going to label our sides. Whatever's across from your right angle is your hypotenuse. Whatever's across from your numbered angle is your opposite. Whatever's next to your numbered angle is your adjacent. So one thing I do when I get to here, I circle what I have and what I need. So opposite and hypotenuse, that tells me that I need to use sine, okay? So this is going to be the sine of 32 degrees. So sine of 32 degrees equals opposite over hypotenuse. So the sine of 32 equals 10 over x. Okay? In our next videos, we're going to explore cosine and tangent, and we're going to actually solve these. But the most important thing to remember here is SOHCAHTOA. Label your triangle, opposite, adjacent, hypotenuse, and circle what you have for a number, and we'll circle what you have for a variable. Once you have that, you can figure out whether to use sine, cosine, or tangent. So here we decided to use sine. Sine is opposite over a hypotenuse because I had the opposite and I was looking for the hypotenuse. All right.